Welcome to this next video. In this video, we're going to be looking at graphs of inequalities. And what we mean by that are graphs of linear inequalities, not x greater than 3, y less than or equal to -5. We want to look at what happens when we're graphing them on the coordinate plane. And so to do that, we're going to take a look at first a website called Desmos, which we've used in the previous video. And now that we're on Desmos, I'm going to type in a linear inequality just so we can see what it looks like when we actually graph it. So just off the top of my head, I'm going to type in 2x plus 4y, and then I'm going to do greater than or equal to, let's go with 8. So when I graph that inequality, you'll notice that it not only graphs that line, if it was just 2x plus 4y equals 8, that's what the line would look like, but it graphs all this other stuff in here, and that is actually the shaded region that is the solution to this entire thing, which is really cool because any single point that is in that shaded region provides a true statement, which means that it is part of the solution. If I take any number in there and plug it into the inequality, I get a true statement. If I flip a couple things around, let's say instead of greater than or equal to, we make that less than or equal to, you see now that we have a different region. It's over in this area here. And you might have caught then when we deleted something here, when instead of making it less than or equal to, it's less than, this line, this boundary line, turns to a dotted line. What that means is that any point that's on that line is not really part of the solution. If I were to take that point 0,2 and plug it in here, I would get 8 is less than 8. That's really close, but it's not quite true. So again, we're going to pay a little bit more attention to detail when we go through there, but just some pieces to keep in mind as we go through. All right, so now what happens? How do we figure this out? So if we're given a graph and we want to figure out, all right, here's my inequality, s less than or equal to 2c plus 460. Let me zoom in a little bit on this if I can. And I can. All right. We want to know if the point 3 comma 400 creates a true or false statement, effectively trying to figure out, well, is this part of the shaded region or not? So if we take the point 400 for S and 3 for C and plug it in, we do get a true statement. 400 is less than or equal to 466. So again, if it's a true statement, that's where we're going to end up shading. All right. So that entire shaded region again is part of our solution set. Okay, so let's get to some examples. And really what it boils down to is we want to figure out which graph, which line looks correct, and then we want to figure out which region is correct. So in this one, we have which of the following is the graph of G is greater than or equal to 7. G is our vertical axis. That's the one that's going up and down. We can tell just kind of the way it's written here. P is our horizontal axis. And again, all the lines are horizontal anyway, so I think we've got that all set up ready to go. But if we look at our symbol, we've got greater than or equal to 7. So immediately based on the fact that it's including the line, I can eliminate B, A, because those are dotted lines. Those are not part of the solution set. So now it's a matter of taking a point and plugging it in. Now this one might be pretty obvious, but I'm not going to make any assumptions. So let's take a point. Let's say we put the point here 0, 0, because that's a really easy one to plug in. Our P coordinate is 0. We have nowhere to plug that in. That's actually okay. We're okay with that. But our G coordinate is also 0. So if I were to take 0 and plug it in here, I would get a statement 0 is greater than or equal to 7. That is not true. So we know that the point 0, 0 would not be part of our solution set. So C does have 0, 0 as part of our solution set. It can't possibly be that one. D is our best choice based on what's left. If we wanted to, we could take another point and plug it in to verify, but it's not really necessary to do that because we've already got our correct answer. We already know it's that one. This one's a little bit different here because now we've got C, which is our horizontal axis, as less than or equal to 90. So just like we talked about in a previous video, when we have a situation where we've got our horizontal coordinate listed out, then that's going to provide us with a vertical line. And so I know because of that, A and B can't possibly work. So it's a matter of C or D. Again, it might be pretty obvious based on that which one it's going to be, but if it's not, and I'm not going to make that assumption, I'm going to take a point and I'm going to go ahead and plug it in. So just like we did before, 0, 0 is a really nice point to plug in because it's pretty basic, right? They're very easy to evaluate. Again, the C coordinate is 0, and so 0 is less than or equal to 90 is a true statement. So based on that, graph D does not have that part of our solution set, but graph C does. C would be my better choice because D doesn't have the right pieces in place. All right, well, what about this one? We've got B plus D is less than or equal to 20. So this is not one of those easy equations where it's horizontal, it's vertical. It's going to be on a slant. And so we have to know how to do something with that. So thinking back to the previous video that we talked about intercepts, that's, I think, the approach that I want to take. I want to figure out what's the horizontal and the vertical intercepts. And based on what I'm seeing here on the graphs, if I look at all these choices here, it looks like D is the vertical intercept. So to find the vertical intercept, I'm effectively ignoring this one here. The horizontal is going to turn into 0. So I know that the intercept of this, and ignore the inequality too, because we're really talking about how do we graph that boundary line, D has to equal 20. And so if I look at my choices here, all of them have D's equal to 20. All right, so I haven't been able to eliminate any of my choices. I do the same thing with B. So B, again, is my horizontal intercept. So if I look at B, D is out of the picture. B has to equal 20. So it could be A, it could be B, it can't be C because that doesn't, that horizontal intercept's way over there somewhere. And same thing with D, so it can't be that one. So it's going to be either A or B. Now they're both less than or equal, the solid line because of that equal to. So I can't eliminate the choices based on that. So again, I'm going to pick a point, plug in. So I'm going to take the point 0, 0, which again, it's on either side of the boundary line. So it's a very easy one to plug in. You could pick any point you want, but 0, 0 is very easy to plug in. So when I plug 0 into here and 0 into here, I get 0 is less than or equal to 20, which is a true statement. Again, if it's true, then it's part of that shaded region, so it's got to be choice B. All right, let's get to one where maybe it isn't quite so clear, which is, whoa, there's the one I want to look at. All right. T is greater than or equal to 1/2 m. So what I'm looking to do is take these graphs and figure out which one is it. T is my vertical axis, M is my horizontal axis. So immediately what I notice is that all of them go through 0, 0. So that strategy I had of taking 0, 0 as my boundary point just isn't going to work. So I might pick a couple points here that are common between others. So I'm going to pick, I don't know, let's just pick the point like 12, comma 4. Because on 2 of those, it does show up as part of the region, and 2 of them it doesn't. So from there, I might be able to eliminate down to 50-50. So if M is 12, and well, actually, let's just do 12, 0. That makes more sense. 12, 0 works perfectly. All right, let's do 12, 0. And when I plug in 0 in for T, I'm going to get something like this. 0 is greater than or equal to 1/2 of 12. So 0 is greater than or equal to 6. That is not true at all. So I know that any inequality that has the point 12, 0 in it as part of the shaded region would not work. So B and C are not going to possibly work. So it's a matter of A or D. And so here I might actually go and try and figure out what the slope is, or I might just find another point that is part of A but isn't part of D, and that might be able to help me find something. So looking in the region of 20, there's really nothing in this area here. But if I go to 20 here, and it looks like 20 comma 20 is in there. So let's plug that in. 20 for T, 20 for M. And I've got 20 is greater than or equal to 10. Based on my graphs here, that one wouldn't work because that's not part of the shaded region, but that one is. So again, it's a matter of eliminating some choices based on some key pieces of information. If it's a slanted line, find your intercepts, and that can help you eliminate some choices there. And then from there, pick a point, maybe two, to help you eliminate and figure out which of the solution sets it's actually going to be.